In these environmentally aware times, connected construction and the autonomy it enables is bringing new levels of sustainability to construction projects, delivering 25% gains in efficiency and reductions in emissions.
As you know, Trimble's making significant investments in autonomy, and some of what we're seeing, the connection, which is really phenomenal, actually is in the reduction in fuel usage and associated greenhouse gas emissions through the application of autonomy, or rather through autonomous operation of machines. Again, we did a study just recently looking at the improvements with pass-to-pass counts, and overlap actually is the key thing. So overlap in the passes with an autonomous compactor, and we saw a 25% improvement, or I should say a 25% reduction in greenhouse gas emissions through using an autonomous compactor on the site. 25% is pretty phenomenal. That's a big improvement. And so we're really excited about how autonomous machines can really have a meaningful impact on sustainability, on greenhouse gas reductions. And of course, I think materials usage is another real opportunity in the industry. We see, the statistics, and I don't have them in front of me, on materials wastage in the industry are horrifying, and clearly an opportunity we have to make a difference in the industry and to make a difference in the world. Obviously, tracking of materials on the site is a key initiative for us, and how you lay down those materials and track that material laydown to minimize the wastage of materials is a focus area for us here at Trimble.
Magnus, I'm going to ask you the same question, really. We know that sustainability is a key driver. In what ways can your technology help the industry to reduce materials and supply chain costs? And it's about management of resources, isn't it?
Agreed. I think just by simply using machine control as it is today, before going to the next steps, we can simply just use the same model across from the machines to any other worker on site which is using the 3D data, which means that we're working on every different lift or every level of the model, which will increase or make sure that you are using the same or the right amount of levels of material. I mean, we know how it is when you're not bulking the right material out, then you might have to fill in with more expensive material, and then all of a sudden it starts to be both waste, right, and also increase the cost of material. And so I've always said that you need to, the logic is to use the same model across the site, use the technical spec properly, and then you will start already there to actually save what I believe is the first step of sustainability. Then I agree with Elvin, there's a lot of initiatives from all of us, I think, into the same directions. But I think only there we should start. We should start to use the systems as they are today. Then we will get a lot of waste off, and we will follow the spec as well. So quality will increase at the same time.
Reducing carbon fuel consumption with technology. Murray, what are your thoughts?
As far as sustainability, honestly, the sooner you start implementing technology in a project, the more impact you can have. If you go even back in the beginning in the design phase, if the engineer uses technology to balance the site, so you're limiting the amount of cut that needs to be exported or the amount of import that needs to come in, that's a lot less trucking. Carbon footprint is greatly diminished. You go to the next stage where the contractor is actually planning on moving the material on a job site. And if they, using the software that's available today, can plan their haul routes and minimize their haul routes and make sure that they move that, as Magnus said, move that material only once, that's much more efficient. It's producing a lot less carbon because we're minimizing the amount of equipment that's being utilized and the amount of time it's running on the job site. It's all about being as efficient on the job as you can, and the machine is maximizing the machine productivity. And then last, if you look at the paving, the paving industry has had automation for 70 plus years, but they've been doing it the same way. And if you look at resurfacing, there's 4 million miles of paved roads and just in the US. And you get roads that over time they deteriorate, and so we go out and we want to fix the road. Well, nobody goes through and really analyzes the road because you're going to have to shut the road down and go off and survey it and what's the real condition. So they do this kind of mill and fill. You go out, you take a certain number of inches off, a certain thickness off, but when you just mill a thickness, the road then is really the same, looks just the same, but it's that many inches lower. And then they come in with a paver and try and smooth it out. But what happens is then you've just kind of made it look good and you've smoothed it out a little bit, but in 3 years, you're back doing the same thing, the same wear and tear. And if we could take the technology that's available and go scan that road, look and see what the condition is. As a matter of fact, whether it's a state or a county or a city could go off and they could scan all their roads. So they could analyze which ones are in the poorest conditions. So then they can take their software that allows them to create what is the best design for that road.